Hello guys, welcome. My name is Nana Kofi Usubediako. I'm your instructor for this revision course in additional mathematics. Most of the students who are doing your O-level IGCSE Add Maths, this course is designed for you. It is a program or a course that is designed just to take you through the basic and important components that fit all the other aspects of your additional maths course. As you may be aware, your course is made up of some 8 or 9 sections, 7, 8 or 9 sections of topics in additional mathematics. So this course will take you through all those sections to make it easier for you to understand. In this particular video or this set of sessions, we will be discussing series. And I guess you know that the series component of your additional maths has got binomial theorem, series and sequence, that's for arithmetic progressions, AP, and also for geometric progression. Okay, so in the set of videos that you'll be watching subsequent to this, you would realize that we'll take each of the parts. The binomial will take you through all the rudiments, the essential portions that you need to know, and what to look out for in the exam. We'll take you through arithmetic progression and discuss all the other components that you have to know, and we'll cap it off with the geometric progression aspect. I encourage you and entreat all of you to take rapt attention, focus, practice with your calculators and all the equipment that you have, and I'm sure you're going to enjoy your video. Thank you very much. Catch you. I'm sure probably if you've gone through the regular course, if you are subscribed to it and you have looked into the aspect of series where we discuss arithmetic progression and the rest of the sequence, it's very clear to you what these things are. In this introductory part of our revision course, we are just going to review some of the key parts of an arithmetic progression, and we will see the expressions or the formulae that we'll be working with as we go along in the rest of the videos as we review some of the important parts. We know what an arithmetic progression is. Any kind of sequence of numbers in which there is a constant number that is either added or subtracted along the line. That is arithmetic progression. We know that for an arithmetic progression, any future term or any unknown term along the sequence or along the progression is found by the term Tn. That's the description. Some other literature may use in it. And keep at the back of your mind that in your examination, it is not always compulsory for you to look out for a Tn as a label for the future term. It could be anything else. We could use K, Q, Y, any letter at all. Any description is possible. But for the purposes of our video and what we'll be doing, we choose to use Tn. So Tn is just a general letter that is probably used by us, but others may use other things. So a future term or any unknown term in arithmetic progression, Tn is given by A plus n minus 1 d. Now, to just help you to remember what we've just discussed, A refers to the first term of the arithmetic progression, n refers to the particular term that you are interested in, and d refers to the common difference. That is that constant number that separates each of the terms. That is what we call the formula for the arithmetic progression, trying to find the terms in there. So, for example, if you have 2, 3, 4, this is an AP. How do we know that it's an AP? If you take 3 and look at 2, the difference between them is 1. 3 and 4, the difference between them is 1. So anytime you have that same difference running through, we say that you have an arithmetic progression. There are times that this difference may also arise out of a subtraction. That is, you may have a negative situation. Let's say if this were 3, 2, 1, then you would see that here there is a reduction of the sequence as you go along. So from 3 you go to 2, which means subtract 1. From 2 you go to 1 and all that. Hence the common difference for this one is negative 1. We are saying that for any of them, let's take this. A will be 2, our n refers to a future term, and d refers to the common difference in there. Sometimes also in arithmetic progression, you may be given the last term. Let's take 1, 2, 3, and it goes to any other number. Let's call it L. That's the last term. We are saying that when you reach the last term, you have reached the end of the sequence. So in fact, the term that is described as the last term is also equivalent to the number of terms in the arithmetic progression. I don't know if that is clear. Let's say, for example, you have got 15 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 15. The last term is 15. Since the last term has the number 15, what it also means is that it represents the number of terms. So the number of terms, it's also in a way equivalent or equal to the last term. Hence, we are saying that for any given term, let's refer this as the first point, for an arithmetic progression where the last term is given as L for last term, we are saying that it is also equal to A into bracket n minus 1d, A plus n minus 1d, in which case this n will refer to the number of terms. The n refers to the number of terms. So anytime you have an arithmetic progression that the last term is stated, if you were to slot the last term in place of where the L is, find your A, that is the first term, the common difference, and you try to simplify using algebraic means, the value you get for n, it's equal to the number of terms in the arithmetic progression. All right. So now that we are clear with that, let's come to the other section of an AP. That is the sum of terms of an AP. The sum of terms of an AP. The sum of terms of an AP is referred to as Sn. So the Sn means that the sum of the number of terms. So if you have an arithmetic progression, 2, 3, 4, 5, 6 of any order, we are saying that its sum of terms, the sum of any terms you're interested in, either you want to find the sum of the first 4 terms, the sum of the first 6, 8, any number of terms at all that you want to find in an arithmetic progression, we are saying that that is represented by Sn. Again, keep in mind, Sn is a conventional use in mathematics. That is, it is accepted by most mathematicians. But watch out, in an examination, there could be a red herring. That is, a different designation could be given to the sum of terms where it will not be Sn. So you have to just watch out. Sn, for our purposes, is used for the sum, but it could be any other letter. We could even use Tn to refer to the number of terms. Just note that for purpose of exam, if there is a change in Sn, watch out that the question will obviously try and let you know that these are the differences that you have there. All right? Okay. So now, when we say Sn for the sum of the terms of the terms is given by n over 2 into bracket 2a plus n minus 1d. Okay? This is the relation we use in finding the sum of terms of an AP. The sum of terms of an AP. I'm sure you remember that, so just keep that at the back of your mind. So n refers to the number of terms that you want to find a sum. Then, of course, the A and D common difference and the first term and common difference respectively, as we know. Now, in the event where you have the last term of the AP, there could be a relation where we can have the last term being given, and we can quickly also find the number of terms, like find the sum of the terms, especially when we know the last term. How do we do that? We'll just go to the derivation a bit. Now, when you look at this here, this Sn could be written as n over 2 into bracket. Let's split this. You're going to have a plus a, so that a plus a gives you 2a, plus n minus 1d. Okay? Now, since we know that the last term is a plus n minus 1 all multiplied by d, we can take the whole of this, the a plus n minus 1 all multiplying d, we can take it, which from this point we are saying that is equal to L. Come to this part, remove that and put the L there, such that the sum of terms of an AP where the last term is given, guys, that's the point, where the last term is given is n over 2 into bracket a plus L. Hope you're okay with that. So when the last term of an AP is known, the sum of terms, Sn, will be n over 2 into bracket a plus L. So guys, these are the 4 important parts or rules that you should know when you have any problem that has got to do with an arithmetic progression. The number of term or unknown term, where you have the last term, the sum of terms, and also the sum of terms given when you have the last term. So always need to have this at the back of your mind when you are going to the exam hall or writing in it, you are going to the exam hall, or you have problems that you have to work with on the arithmetic progression. So that is it. In our subsequent video, you will be going through examples that would make use of most of these expressions. So I'm sure you will find it very easy working through it. Thank you very much. Stay tuned.